In this video, we're going to look at topic 35, example 2, factor out the greatest common factor. We're asked why is it helpful to factor out the GCF from a polynomial, and then we're asked to consider the polynomial negative 12x cubed plus 18x squared minus 27x. So this is quite similar to the previous video. We're going to look for the GCF, or the greatest common factor, but the difference this time is we're going to actually factor out, and you'll see what that means in a moment. So we're going to do the same thing. We're going to take our terms, and I'm going to write the whole process out. Once again, I'm going to ignore the negatives for now. We'll talk about that in just a moment. So factors of 12, we did this in the previous problem, but we have 1 and 12, 2 and 6, 3 and 4. Again, I like to pair them off, whatever method works for you. And then we have 3 x's. 18, 1 and 18, 2 and 9, 3 and 6. And that would be it. And then 27, we have 1 and 27, 2 does not work, 3 and 9, 4 does not work, 5, 6, and 7, and 8 do not work. So we only have 1, 3, 9, and 27. Forget about our x's here. Okay, so for this specific problem, let's try to figure out the GCF. All right, so the GCF, the numbers that they have in common, the greatest common factor would be a 3. All right, 4, 6, and 12 are not in the other one, so greatest common factor would be a 3. And then I only have one x that I can take away from each one because the smallest one or the lowest degree would be x. So we have a GCF of 3x. Now, that's not the final answer. We are going to factor this one. So we're going to look at negative 12x cubed plus 18x squared minus 27x. And what we're going to do is we're going to factor out a GCF by dividing each term by 3x. So think of this as undoing distribution. Right? So it would be 3x multiplied in. Now, what I do want to point out, and I mentioned this in the last video and just before, we do want to look at this negative here. We generally do not want our leading term to be negative. So to get rid of that, we are going to divide or factor out a negative 3 instead, because a negative divided by a negative would create a positive number. Okay, so we want our leading coefficient to be positive. So from here, you're going to divide each term. Negative 12 divided by negative 3, that would give me a 4. So this is the number that we're looking for to be positive. Okay, so we want this one to be positive. That's why we factored out that negative. And then x cubed divided by x. Think of x cubed. Oops. So x cubed divided by x is x over x. And we can cross out or eliminate one from each side, so we're left with x squared. What you'll wind up doing is you'll wind up subtracting the exponents. So 3 minus 1 would give you that 2. I'll keep that down there. And then 18 divided by negative 3 would be negative 6. So if we have x squared over x, right, we would cancel one out from the top and the bottom, so we'd get 6x. And then negative 27 divided by negative 3 would be a positive 9. X over x, they both cancel out. So that's what we would be left with. So let's get rid of this work down here. So now that we've factored out that negative 3x, this would be our factored form. What you can do to check it, you would stop there, that would be the end of the problem. But to check these, think of factoring as undoing distribution. If I was to take this negative 3x and distribute it back in, I should get back to my original problem. Right, so this here and this here should match up, which they do. The signs are good, the exponents are good. So that's how you could check. But your actual solution or your answer, what you're looking for, is this here. Okay. So first find the GCF. A lot of this writing over here You won't always have to do that as you get better at this, especially with the variables. The variables are a bit easier to figure out how many you should be taking out. And then just be careful with the division, be careful with your signs. Remember, we want our leading term in parentheses to be positive. That'll become pretty useful for us in one of the next lessons. So if the leading term is negative, you want to factor that negative out. We don't really care if the following terms are positive or negative. We just care that the first term is positive. All right, that is it. Just make sure that those match up. All right, think of factoring as undoing distribution.